Okay, so today we are going to start our chapter number 2, that is consumers' behavior. And in this consumers' behavior, we'll cover 2.1, utility and choice. And in that utility and choice, we are going to deal with cardinal and ordinal utility. First of all, we define what is utility, and then cardinal and versus ordinal utility, and then total utility and marginal utility. The relationship between total utility and marginal utility, and the law of diminishing marginal utility. In section 2, consumers' equilibrium will be studied. And in that consumers' equilibrium, we'll go for indifference curve and the budget line and marginal rate of substitution, MRS, and consumers' equilibrium, both mathematical and graphical analysis. And finally, we'll go for water diamond paradox or paradox of value. Okay, so let's start our first section, utility and choice. So what the fundamental question, first fundamental question is, what is utility? Utility. There is a very short answer to that. That is, this is called power of, or power to satisfy your want. Okay, so suppose you have you are going to consume good X. Okay, good X, consume good X, and then from good X, what amount of utility you are going to get. So how much satisfaction you are going to get from consuming this good X is called utility. So how much satisfaction you are gonna get from this consumption of good X. So I mean, the problem is, the question is, can we quantify utility? So basically the answer is no. But in early years in economics, economists try to make the, quantify the utility and set a unit, and this unit is called utils. Okay, so if I say that consumption of good X, 10 utils, that means you are going to get the 10 unit of satisfaction, 10 unit of satisfaction, 10 units of satisfaction or utility. But there is a problem in quantifying the utility. What is the problem? Because suppose person A says that I'm getting utility from good X is 10. Person B can say that I'm getting utility maybe 11 or maybe 12 or something else. So here is a problem. This problem is called interpersonal comparison of utility. That means utility varies from person to person. It is not objective. That is, utility is not objective. It is actually subjective. That means utils varies person to person. The meaning is that utility varies person to person. Okay, so that's why we can classify utility in two different ways. So types of utility, or classification of utility, not types actually, classification. Classification. And in cardinal utility, in cardinal utility, we can set unit of measurement as utils, but because there is a problem of interpersonal comparison, we cannot say that we can set a unit called utils, but we can rank them. Okay, rank or order utility. Okay, order utility in such a manner that the choice can be said as first choice or first, second, third, etc. Choice can be classified as this. So combination, in that case, we take the combination of good x1 and x2, and then we say that if one is increasing, we'll learn this after this section. We'll learn this. If x1 is increased, then you have to decrease the amount of x2 to keep the utility same. So if it is the first choice, then if you increase both, then it is greater than, suppose x1 1 x2 1 combination. So if it is increased to x1 double prime x2 double prime, then we can say that there is an increment. So you can call this as second order, and that one is first order. So we can rank the combination of goods and services. So in that case, we are not going to take utils as unit, but we can rank them. So in cardinal, we can say that utility varies 1, 2, 3, 4, etc. But in ordinal, we rank utility as first, second, third, etc. Okay, so there is the numerical difference between the ordinal and cardinal. In cardinal, it is 1, 2, 3, 4, 5, and in ordinal, it is ranking first, second, third, fourth, fifth, etc. Okay, so this is the basic difference between cardinal utility and ordinal utility. So what is the difference? Difference is, in cardinal utility, we hypothetically take utils as unit for quantifying utility, but in ordinal utility, because there is a problem of interpersonal comparison of utility, then we avoid this comparison, and we say that we can rank the combination of goods and services into first, second, third, fourth, etc. Okay, so there is the basic difference between ordinal utility and cardinal utility. Now it will be more clear when we take some numerical example of cardinal utility. Okay, so take this as so we have done this defining cardinal and ordinal utility. That now we're going to take the total utility and marginal utility. So suppose your consumption of good X is apple. So you are consuming apple. So when you consume apple, so you can say that if you consume the first apple or one apple, suppose you have taken one apple, and suppose the and you are getting 10 utils. We are talking about the cardinal utility. 10 utils. Okay, so 10 utils. So it is obvious that when you are taking the second apple, if you take this second apple, the question is, do you have the same level of satisfaction in the second apple? Is it 10 utils?
No, sir.
Why not? Brilliant, your answer is correct, but why not? Why you say that in the second apple, you are not getting the same utility?
The utility should be increased when I get second apple.
No, I mean second apple, I mean unit by unit. First apple, 10 unit. Second apple, do you get the same 10 unit? We're not talking about the total utility now. Second apple, 10 units or less?
So it will be changed, not 10 units.
Changed in what way? Positive or negative?
Confused, sir, but it will change.
There is no confusion, because if you take the first apple, your satisfaction level is decreased. So you can take a 9 unit utils of you can get 9 utils or even less, 8 utils or even 7 utils from the second apple, because after taking the first apple, suppose you are taking a glass of water. So first glass of water, you suppose you are very thirsty, and that's why you get 20 utils from a glass of water. And the second glass of water, you are not getting the 20 utils. Okay, so suppose in the second glass of water, you can get only maybe 5 utils. I mean 15 utils. Or maybe third glass of water, maybe you can get I mean 10 utils, because your thirsty is already done. Your satisfaction level is already covered. So utility is going down and down and down. Okay.
Okay, sir. Clear.
So that is the idea. And the third apple, you are not getting the 10 units. Maybe you are getting, I mean, not 9 units. You are getting actually 7 or 8 units. Okay. So that's why we say that in the first plus second plus third apple, your utility level is not constant. Your utility level is going to decrease. Okay, so we can say that there is a total utility. The concept of total utility is total utility from a number of goods and services. So suppose we can make a table here. Table says that one apple, I mean quantity is 1. So when quantity is 1, apple consumption. Make a headline of this: apple consumption and utility measurement. And this utility measurement in cardinal sense. Okay, so quantity is 1, and utils, that means So suppose the first apple is you are getting 10, and the second apple you are not getting the 20, actually you are getting maybe 19. When 3, so you can call it as total utility equals to util. Okay, so then it is not 30. I mean, if you don't consider the diminishing, then you can call it as not 30, it is 27. So when you are getting fourth apple, your utility can be, I mean, on total, your utility is not 40, it is maybe 34. So when you are adding extra apple, it is not 50, maybe it is 40. Okay, so that is the total utility. That means from 1 apple, 10, 2 apples, 19 utils, 3 apples, 27 utils, 4 apples, 34 utils, 5 apples, 40 utils. It is actually 40 utils. So this is called total utility. That means total amount of utils you are getting from consumption of a number of, number means Q, number of good X. Okay, so this is called total utility, and we measure, we can call it as TU. Okay, now, so when we are talking about the TU, we can judge a marginal utility. So what is marginal utility? Marginal utility is when you add one extra unit. That means del Q. So you are actually adding some additional utils. That means here 9. Okay, so first, if it is 0, then 0, then there is no utility. So the difference between 0 and 1 is 1, and the difference between the 0 and 10 is 10. So here 10. Then the difference between 10 and 19 is 19 and 10 is 9. So the difference between, because the difference in this side is only 1, 1, 1, 1, 1. So we can count the difference is 10, 9, 8, 7, and 6. So you can add one more, but enough. 5 may be enough. Okay, so this is called marginal utility. So what is the definition of marginal utility? MU is additional utility taken from n extra units of good X. So if we think about the mathematical sense, marginal utility is del total utility del good X, or del Q. Okay, so Q is amount of good X, amount of good X. Okay, so the mathematical definition is the first derivative of total utility is called marginal utility. So first derivative of first derivative of total utility is called marginal utility. So what is the basic idea? Basic idea is if you add one more unit of goods in your consumption basket, then what is the extra amount of utility you are getting is called marginal utility. And you see that marginal utility is diminishing. That means why diminishing? Because once you are once you have fulfilled your thirsty by first glass of water, in the second glass of water, you are not getting the same level of satisfaction. You are actually, the satisfaction level is decreasing because you are not thirsty right now after taking a glass of water. So your satisfaction level is decreasing. That's why marginal utility is declining. So there is a law, and this law is called law of diminishing marginal utility. So what is the law of diminishing marginal utility? As we increase the number of consumption of a good, suppose apple, the subsequent increment in the number of consumption of good X, the total utility is additional utility from taking the that good is decreasing. Okay, for one extra unit, for one more unit of good X, consumption of good X, total utility decreases. Okay. Okay, so this is actually the rate, and the rate is diminishing or declining. It will be clear when we are talking about the graphical illustration. Okay, so declining. Okay, so now we understand what is the total utility, what is the marginal utility. Okay.
Yes, sir.
All right, so how can we graph them? So suppose in our x-axis we take total utility, and here quantity of good X, Q. Okay, so we can say that our graph is look like this. So it is increasing, and it is taking the max and then declining. So this is our graph for total utility. Okay, and when this curve is concave, this concavity means that marginal utility is diminishing. That is increasing at decreasing rate. Now, if this is the convex curve, it is actually diminishing means increasing at decreasing rate. And this rate is called marginal utility. Okay. Here you see that there is a total utility curve. It is convex. So when it is convex, that means the rate is increasing at increasing rate. Increasing at increasing rate. So mu is increasing or rising. Here mu is falling. Now tell me, if we say that our total utility curve is look like this, what can you say about this total utility? I have graph of three types. One is concave, and I say that marginal utility is diminishing. That means total utility is increasing, TU increasing at decreasing rate. I said that it is convex. So total utility is increasing at increasing rate. Now, what about your decision by this graph? The total utility is
Increasing.
Increasing, but what is the rate? At constant rate. So in our previous graph, so if it is, marginal utility is constant, then 10, 10, 10, 10, 10, not 10, 9, 8, 7, 6, okay? So if it is 10, 10, 10, 10, 10, then marginal utility, total utility is increasing at constant rate. But if it is 10, 12, 13, 14, 15, then it is
Increasing at increasing
at increasing rate, okay? All right. So in that, so how can we draw marginal utility from this graph? We can draw marginal utility from this graph is very simple. So we can take here marginal utility and Q. Okay, Q is consumption of good X. So you see that there is a max, TU max. This point is called TU max. Okay, TU max. And we know from the mathematics, we know that mu is dTu dq or dx. Okay, so this is the first derivative. What is the optimization rule for first derivative? Optimization means either maximization or minimization. What is the optimization rule for first derivative? And this rule is called first order condition. The rule is first order condition, FOC, is when dy dx equal to 0. When dy dx is equal to 0, then it is either max or mean. In order to determine whether it is max or mean, you have to take this second derivative or SOC, second order condition. Second order condition, what is the second derivative of this? d2y dx2. So when second derivative is negative, then it is max. When second derivative is positive, the curve is taking mean, okay? So this is called optimization rule. Optimization rule. So apply this rule here. So when you're talking about the TU max, that means here at this point, TU is del TU, del Q is 0, right? Here?
Yes, sir.
Okay. So if this is 0, that means mu is 0, right? Because we know that this is mu.
Yes, sir.
Okay. So when we agreed upon this, then we can say that this point corresponds to the minimum of this point is 0 mu equal to 0. That means point is this. Okay, agreed or no?
Yes, sir.
All right. Now we say that from origin to maximum, what is the rate? Because the curve is concave, what is the rate?
Increasing at decreasing rate.
Decreasing rate. So marginal utility is going down, right? Because the rate is decreasing, mu
Yes,
is
sir.
the rate. So marginal. So this curve is look like this. Okay, so it is going down and take the 0 at TU max. Okay.
Max. Okay, sir.
So this after the point TU max, TU is declining. That means when TU declines, that means MU is negative, right?
Yes, sir.
So MU is taking negative, so MU go down here. So this is our MU curve. Okay. Okay, so in the first, table, we see that if it is 6, then 5, then 4, then until it is max, then after the max, maybe it is 60 is max. So in this case, it is 0, and then taken negative. Okay, so 1, -1. All right. So here we see that in this point, this 60 is TU max, and MU is 0.
0.
Okay. So if we understand this, then we can take the, we can make the relationship between total utility and marginal utility. So write down the relationship. The relationship between TU and MU. So what is the relationship? So write in this way. First, when TU is increasing at decreasing rate, increasing at decreasing rate, MU is declining. Okay, that means slope of MU is negative. Okay, all right. Point number 2, when TU is at max, MU is 0. Why? Because DTU DQ is 0. Point number 3, when TU is declining, MU is
Negative.
negative. Here slope of MU is negative, but here MU itself is negative. Itself is negative. There is a difference between this one and that one. This is slope and this is MU itself. Okay, so this is the these are the 3 fundamental difference between fundamental relationship between total utility and marginal utility. Okay, maybe we covered our next section is called relationship between total utility and marginal utility. So it is covered. So we have covered 2.1.1, we have covered 2.1.2, and we have also covered 2.1.3. Now, what is next? Law of diminishing marginality. It is already covered because from this table, we have seen in the first table, law of diminishing marginal utility. So what is the law of diminishing? When you add extra unit of apple consumption, then total utility is declining at, total utility is increasing at decreasing rate. That means marginal utility is declining. The rate is declining, that means marginal utility is declining. So that is the law, and this law is called law of diminishing marginal utility. Okay, so it is also covered. Now, what is next? Our next point is consumer's equilibrium. So before going for consumer's equilibrium, let's discuss these cardinal utilities in mathematics. I mean mathematical function. Cardinal utility. Suppose we have two goods, x1 and x2. Two goods, x1 and x2. Okay. So if two goods are there, mathematically we can say that utility is a function of x1, x2. And here you use ceteris paribus. Why? Because we are not sure. I mean, we can't lead our life with two goods. So we keep our all other consumption of goods and services constant. So ceteris paribus. Now, here you see that there are three variables. One is dependent variable. And this dependent variable is actually u, and two independent variable. And these are variables, and these are x1 and x2. But our space is two-dimensional. That means our Cartesian is two-dimensional, right? So we can take only only two of them. In order to draw graph, we can take only two of them. So suppose we take this one and any of these two, x1 and x2. So our cardinal utility turns to total utility in cardinal sense. Total utility is a function of only suppose x1. Now we have two variables, total utility and x1. So suppose in this axis we measure x1 and in this axis we measure t. So again, ceteris paribus, we keep it as a constant. Okay. So when we increase consumption of good x1, total utility also increase, but this increment is at declining rate, decreasing rate, because of the law of diminishing marginal utility. So this is actually cardinal utility, one good at a time, total utility, and then we draw the function like this. And from this we can take dtu, dx1, and this one will be marginal utility, and marginal utility is like this. So x1 marginal utility. So this is taking 0. So our marginal utility is mu. Okay, mu x1. Okay, so here is the mathematical and graphical illustration of cardinal utility. Okay, now what about ordinal utility? So ordinal utility, let me write down here. Ordinal utility, again, function. Utility is a function of x1 and x2. Okay, so in ordinal utility, which is equation 1. So in ordinal utility, we say that we are going to rank ordinal utility. Rank order. That means our utility should be first, second, and third. Okay. So here you see that again three variables. One is dependent variable, and other two x1 and x2 are independent variable. So we can increase our rank order. That means first, second, third, etc. So we can increase our rank order, or that means utility. That means utility can be increased by this way. So when you increase both x1 and x2, increase both x1 and x2, then utility becomes u1 to u2. Okay, so if this is first utility, first order, this could be second in rank, first rank, second rank. So again, we use increase both x1 and x2. So it may be third, u3 may be third rank. So in that way we can find the rank order. Okay, so in order to draw this curve, we need to make one constant. So suppose we are making this one constant. So when you make this constant, so in order to make this constant, you have to increase one and decrease other. Okay, so for making u constant, why I'm making constant? Because we know that in two-dimensional space we can't take three variables at a time, so we take two functions at a time. So x1 and x2 are taken. So if you increase x1, you have to decrease x2. Okay, so in that case we can keep the utility constant. Okay, so when we take the utility constant, then we can say that it is ordinal utility. So if we increase both x1 and x2, our utility increase in the rank order. If we want to make the utility constant, then you have to increase. If you increase x1, you have to decrease x2 in order to make the u constant. Okay, so in this can be shown in the table. So suppose our rank is, suppose our combination is called combination of goods and goods called A, B, C, and D. We have three combination of good x1 and x2. And our consumption of good x1 here and consumption of good x2 is there. Okay, so suppose consumption of good x1 is suppose first combination is 3 and 8. So this is a combination. So we are going in combination A, we take 3 units of good x1 and 8 units of good x2. So if let u is constant, so if you increase the amount of x1 by 1 unit, that means 4, then you have to decrease the amount of good x2, maybe 5. Why? Because if you want to increase the x, because this is constant, you have to decrease the amount of good x2. Again, you increase the amount to 5. You have to decrease again by maybe 3. Again, you increase by 1 unit, 6. This can be 2. So in one side x is increasing, x1 is increasing, the other side x2 should be decreasing. Why? Because our utility is constant. So this is the table, and this table can give you a graph, and you can draw a graph from this. So suppose here your x2 and there x1. So and x1 is increased by unit. Suppose this is 3, and this is 2, and this is this is 4, and this is 5, and this is 6. So for 3, 4, 5, 6, our x2 consumption is 8. Suppose this is our 8, and between is 4, this is 5, and this is 6. Okay, so combination of 3 and 8 is point this. Combination of 4 and 5 is 4 and 5 is point this. Combination of 5 and 3 is, suppose this is 3. 5 and 3 is this. Combination of 6 and 2, suppose this is 2, is here. So this point is A, this point is B, and this point is C, and this point is D. So if you connect this, we get a convex curve. And this convex curve gives you this same constant utility. Constant utility. Okay, constant utility at each point A, B, C, etc. So there are millions of points on this curve, each and every point giving you the same level of satisfaction or same level of utility. Same level of utility. Okay, so if they are giving same level of utility, that means if you move from here, if you move from here to there, so 3, 8, 4, 5, then 5, 3, and then 6, 2. This is 2. So if we move, you are going to decrease the amount of consumption of good X if you want to increase X1. So this is called sacrifice. Sacrifice, and sacrifice is add 1 unit of X1. You have to sacrifice some X2, some unit of X2. So sacrifice means declining X2. So this is called marginal rate of substitution X1, X2. So how do you measure marginal? So for one marginal rate of MRS X1, X2 is dx1 dx2. Sorry, dx2, dx2 dx1. That means so X1 is increased by 1 unit. So this is 1 unit, this is 1 unit, and this is 1 unit. So you are increasing X1 by 1 unit. So for 1 unit additional, consumption of X1, you have to sacrifice some unit of X2, and this is the definition of MRS. Okay, so how do you define MRS here? So there is a data for MRS here. So difference is here, 8 minus 5 is 3. So MRS is 3 here. So difference is 2 and difference is 1. So MRS is 3, 2, 1. Okay, and now you see that MRS is also decreasing, like diminishing marginal utility. Now tell me, when MRS is constant, what could be the curve look like? Suppose MRS is 3, 3, 3, 3. What is the shape of the curve?
It will be straight line, sir.
Straight line. Okay, thank you. Straight line. So when MRS is constant, then it is straight line. So when MRS is increasing, suppose it is 3, 4, 5. What could be the curve? It is
It will
obviously
look like a concave.
Concave. So it is concave. So in convex, MRS is decreasing. In concave, MRS is increasing. In constant, in straight line, MRS is increasing. But normally, we see in the economics or in the economy that this curve is look like this. Okay, so there is a name for this curve, and this curve is written, and the name of this curve is written is indifference curve. So indifference curve can be drawn like this. So it is like this, and this indifference curve has some properties. So why it is called indifference curve? Because consumer is indifferent whether he is on this point, on this point, or on this point, or on this point. Why? Because all points, consumer is indifferent suppose it is A, point B, point C, point D. Consumer is indifferent among various points on IC. This is called IC. Okay, indifference curve. Why? Because this is because A, B, C, all points give same level of satisfaction. Why? Because if it is x2 and if it is x1, so if you want to increase the consumption of x1, you have to decrease the consumption of good x2. Okay. So what are the properties of properties? IC. So properties of IC is number one. IC is convex to the origin. Why convex to the origin? Because we know that MRS x1, x2 is normally declining, decreasing. Property number two, each point on the same IC gives same level of satisfaction, same level of satisfaction. Why same level of satisfaction? Because utility is constant on the curve. Property number four, higher IC gives higher levels of satisfaction, levels of satisfaction. So we can add, I mean, another IC curve, and if this is the first ranking IC, this could be the second ranking IC. So IC2, why second ranking? Because we are increasing both X1 and X2. So both X1 and X2 increase. That means your rank increased. So higher. So if we shift IC curve, the higher level of satisfaction is there. Okay. So if we add another IC, that means you are adding, I mean, third rank, IC3. So when there is a various ICs are on the same graph, this is called indifference map. And only single IC means indifference curve. Now, we are going for the fifth property, and fifth property is property number 5. Fifth property is no two ICs intersect. That means that is ICs are parallel to each other. Parallel to each other. So we are going to prove this. So take proof of that. So how can we prove this? Let us prove this. So proof is, suppose not. Suppose they are intersect. What will happen? Suppose we have IC1 is this and IC2 is that. Okay. So suppose these are two IC. Now take these two, take some points. So this is a common point B, and this is A, and this is C. Okay. So let's go for formal proof. So suppose IC1 and 2 intersect. What happens? So we can say that for IC1, utility from point A equals utility from point B. Why? Because they are on the same utility. That's why they are same. For IC2, utility from C equals utility from B. Okay. So by this token, we can say that utility from this utility from A equals utility from C. But notice that this violates one of the properties. What is the property? It says that property number 4, higher IC gives higher levels of satisfaction. So obviously C is in the lower utility curve and A is on the higher utility curve. So this is not right, that A utility from A equals utility from B. So our supposition, that means our this notion contradicts. So what is the decision now? Decision is IC1 and IC2 never cross. Okay. All right. So we have covered IC curve. Our next point is budget line. Okay. So here you see that when we use the indifference map, so we are going higher, sky limit. Can we reach sky limit? We can't reach sky limit. Why? Because scarcity. We don't have enough resources to reach the sky limit. So that's why we need to take a constraint on that. And this constraint is called budget. Okay. So when you go to a shop and you buy two goods, maybe shirts and pants for your Eid, then you tell the shopkeeper that I have this much money. That means I have a budget. So within this budget, can you give me a pair of pants, trousers, and a shirt? So knowing this budget, the shopkeeper will offer you a pair of trousers and pants. That is the budget. With this limited amount of resources, we are going to reach the highest possible. So we can't reach the sky limit, but we can reach the highest possible IC. So that's why we need a budget line. Okay. And budget line can be formed in this way. So suppose our income is M. So for good X1, there is a price of P1, right? So for good X1, per unit price of X1 is P1. So the total amount of money spent on P1 is X1 P1. And if the price of good is P2, amount is X2, per unit price is P2, then we can say that our second item can be bought by total amount of money is X1, X2, P2, X2, or X2, P2. We can write in the, nice way is M equals P1 X1 plus P2 X2. So here P1 X1 is total amount of money spent on X1, and P2 X2 is the total amount of money spent on X2. Okay, so together it becomes the total budget. Okay, so the budget line can be drawn because it's a straight line equation. Budget line can be drawn in this way. So this is our budget line now. Here X1 and X2. So when we are here, point here, we are out of capacity. We can't buy anything when if we are here, capacity. When we are here, we don't use resources properly. That means some amount of money is left for your buying trousers and shirts. So when you are on this line, that means you are spending all amount of money in a particular combination of goods and services. So here, there, or on that line, there are many combination of X1 and X2 you can buy with your budget M. Okay, so this is called budget line. So budget line M equals P1 X1 plus P2 X2. Okay. Now we can find the maximum possible utility curve. How? So when we get the maximum possible IC, then it is the consumer's equilibrium in that sense that we can combine these two graphs. So we have IC map. So suppose this is our budget line. So this point is, and suppose there is a IC here. So IC1, IC2, IC3, IC4, etc. IC5. We can reach maximum IC is IC2. Here you see that maximum IC2. Why? So this point, this is X1 and this is X2. So this point is X2 star, maximum possible amount of X2, and this is X1 star, and we reach the consumer's equilibrium X1 star and X2 star. So what is the main idea of this consumer's equilibrium? This main idea of the consumer's equilibrium is when IC is tangential to budget line. This budget line is called BL, and this is IC. So when IC is tangential to the budget line, then we can get the consumer's equilibrium. No other, here IC is IC2. No other IC is equilibrium IC. Why? Because IC3, suppose IC3. So can you tell me why IC3 is not, equilibrium IC? Can you tell me?
So it is out of the budget line.
Out of budget line, or out of capacity. You see that it is out of capacity. So it is not equilibrium. Okay, so IC3 as well as IC4 and so on, they are not consumer's equilibrium. Now, what about IC1? Can you prove that IC1 is also not equilibrium? We can prove in this way. Suppose, for IC1, it is not tangential. It is actually crossing point, suppose point B and point C. It is not tangential, it is point A is tangential. Point A is tangential. Point B is cut point, not tangential. Okay, so our property for equilibrium consumption says that for equilibrium, IC should be tangential to the budget line. Now, point C here and point B there is not tangential point. So that's why IC is not equilibrium point. Let me be clear about that. So suppose A, B, C, all are on the same BL, right? And we say that on the same BL, they are all efficient point. So all are efficient. Okay, so when all are efficient, then we have said that only one point is equilibrium. We can't say that B and C are equilibrium. Why? I say again, all points A, B, C are on the same budget line. Okay, so that's why they are all efficient point. A, B, C, all are on the same budget line. They are all efficient point, but only one is tangential. That's why it is equilibrium point. And B and C are, although on the same budget line, they are efficient point, but not equilibrium. Why? Because IC, they are on the same IC, but they are cutting the budget line. So we can use the property. Look at this property. We can use this property to prove this. What is the property? Property number
4.
4. So property number 4 says that higher IC gives higher level of satisfaction. So here you see that although point B and C, although I'm writing here, although point B and C are efficient, actually A, B, C and are efficient. Point A is on the higher IC. So higher IC means higher level of satisfaction. So
Yes.
we can say that satisfaction from A is greater than satisfaction from B and C. So that's why point B and C cannot be equilibrium. Point A is equilibrium. So that's why point A is consumer's equilibrium. So in this section, we have covered indifference curve, we have covered marginal rate of technicals, marginal rate of substitutions, and we have covered consumer's equilibrium graphically. So our utility is we said that our utility is a function of x1 and x2. So we said that our graph says that equilibrium point is tangential, okay? This point is tangential. And this point means that tangential point, what does it mean? If this is IC and if it is BL, then slope of IC equals slope of BL. That is the tangential point, meaning of tangential point. We will apply this notion into our mathematical analysis. Okay, so if we take the total derivative of this, so our du is equal to partial derivative del function of x1 x2 divided by del x1 times total derivative derivative of x1 plus del function of x1 x2 divided by del x2, and this du equals what?
And the total utility.
Total utility, but equals what value? According to the definition of IC, we say that when you move from one to place, other place, that means du from A to B, utility doesn't change. That means utility from A and utility from B is the same. So what is the value of du? I said that on a single IC, utility gives the same level of satisfaction. That means utility from A and utility from B are same. So what is the value of du?
1, I guess.
No, it is 0. Why 0? Because there is no change in utility. So when this is 0, then we can find the slope of IC here. Slope of IC. So what is the slope of IC? Just rearrange this, and your slope of IC is dx2 divided by dx1 equals minus del. Just rearrange. You can add some extra lines here. Del function of x1 x2 divided by del x1 whole divided by del function of x1 x2 divided by del x2. Okay, so this is the slope of IC, and this is actually, we learned from this, is actually minus MRS x1 x2. We have seen in the earlier pages. Okay, so now tell me, what is this del function of x1 x2 del x1? What is the meaning of this? That means this is actually del tu del x1. What is the name of this? Can you remember? Mu.
Yes,
Thank
sir.
you. Mu x1. So this is actually mu x1. And what is that?
Mu x2.
Mu x2. So finally, we have seen that our slope of IC, this slope of this is actually what? Minus, because it is downward sloping, minus mu x1 divided by mu x2. Okay, so this is slope of IC. But how can we find the slope of BL? Any idea? This is also very easy. So we know that P1 x1 plus P2 x2 is M, right? So this is our BL. So we can say that P2 x2 equals M minus P1 x1, right? That means x2 equals M divided by P2 minus P1 divided by P2. Okay, so now we take the first derivative. This will be slope of BL is dx2 dx1. So it is minus P1 P2. Why? Because this is the slope.
Yes, sir.
All right. All right. So we know that as we learned from the previous page, that slope of IC should be equal to slope of BL. Now we can find the equilibrium equation. Equilibrium equation. So what is the equilibrium equation? Equilibrium equation is minus cancel out. So MUX1 divided by MUX2 equals P1 divided by P2. Okay. So this is called law of equimarginal principle for good x1 and x2. Now this is law because if x1 x2 up to xn, so we can say that mu x1 divided by mu x2 equals, okay, so we can convert this into beautifully, we can convert this into mu x1 divided by p1 equals mu x2 divided by p2. So for beautification only, so you can write in this way: for n number of goods, mu x1 divided by p1 equals mu x2 divided by p2 equals mu xn divided by pn, which is constant because it is a law. It is constant. So this is our final equilibrium equation. Okay, so we finish our mathematical side of the consumer's equilibrium. So this ratio is called law of equimarginal principle. Okay, now our final point is water diamond paradox. Now, can you tell me what is paradox? Paradox means puzzle, okay? Puzzle. Why water diamond paradox is there? Because in the economy, water, we say that water is life. And diamond is I mean, can you survive without water?
No,
Yes or
sir.
no? No. Can you survive without diamond?
Yes, sir.
Yes. So diamond is not necessary for life. Not necessary for life. Water is very necessary for life. Without water, we can't survive. We can't survive. Okay. Now the puzzle is water is low priced, although it is very necessary. Not necessary, it is luxurious. Diamond is luxurious. Luxurious good. So it is low price, but diamond is, although not necessary for life, diamond is very high price. Very high price. That is the puzzle. Can you solve this puzzle? this puzzle was puzzle until we develop the idea of marginal utility. We develop the idea of marginal utility. So when economists were not aware of marginal utility, they were aware of total utility. Okay, so they said that total utility is determining factor for price. But by total utility, you can't solve the puzzle. You have to take the marginal utility concept. And this marginal utility concept, we have seen that there is a law, the MU and diamond, MU water divided by price of water equals to MU diamond divided by price of diamond equals to a constant, right? So we can solve by this equation. By this equation, we can say that y price of water is low, y price of diamond is very high. Now take this example. Now can you give me MUW and MU diamond? Which one is higher? MU means if you have one unit and if you want to add more unit, then what is the level of satisfaction, extra satisfaction you are getting? So if you consume one glass of water, the next glass of water is useless. That means you are thirsty. So one glass, at best 2 glass. If you are very thirsty, then third glass, no, enough. But what about this? 1 unit, then second unit. Do you say enough?
No, sir.
So it is very high. So marginal utility is very high. And marginal utility of water is very low. Now use this equation. Suppose lambda is 2, constant. You can take any constant, no problem. So we say that marginal utility of diamond is very high. Suppose it is 1000. And marginal utility of water, as we believe that water is very low, suppose it is 2. So now you use this equation. So 2 divided by maybe price is, so if it is 2, then price should be maybe 4, right? For lambda equal to 2, price should be 4, right?
Sir, oh, should be 1.
Okay, right. Thank you. Price should be 1. All right. So 1 unit. Thank you. Thank you for the correction.
Welcome.
So now, if we say that the MUD is, we say that MUD is 1000. So what should be the MU price of D?
500.
500. So that's why price of water is low and price of diamond is high because of this constant. Why this is the case? Because marginal utility for water is very low, because we don't want more glass of water, although the glass of water is, although water is very necessary good, or we cannot survive without water. But diamond, although it is not necessary for life, the marginal utility of diamond is very high. So that's why the price is also very high. So that's end our chapter 2.